Hi and welcome to Geeks for Geeks. If you are attending this session, just send me a quick +1 in the chat so that I know. Let me just turn on my preview screen so that I know I'm visible. Okay, fair enough. Let me just refresh the screen so that I start receiving the. Okay, fair enough. Let's proceed to today's session. Today, we would be discussing yesterday's problem of the day. What happened? Just a sec. Yeah. Sorry about that. I didn't connect my USB hub. Okay, fair enough. Today we would be discussing yesterday's problem of the day, that is Spidey sense. Okay, and this problem is a medium level problem with success percentage of 86%. Now, before moving to the problem statement, which kind of has a little bit more complicated algorithm to use, let us discuss a simple question and then we would enhance that question and we would solve this question. Okay, so let me give you a question. Now suppose you have a matrix. Okay, let's not have a matrix. Let's start from the very ground level. Okay, basic level. Now suppose you have different cities. Suppose this is your first girlfriend's house, this is your second girlfriend's house, this is your third girlfriend house, and this is your fourth girlfriend house. Now suppose this is you. Okay, this is you. Okay, and this is a graph where you all are interconnected. Like girlfriend 1 has a path from girlfriend 1 sorry, let me draw it here. So girlfriend 1 has a path from G1 to G3, then there is a path from G2 to G4, then there is a path from G2, and then there is a path from U to G4. Okay, suppose this is okay. Yeah, thanks a lot, Lalit. So you have 4 girlfriends and this is you. Now suppose this is it is told that this is a graph. Now I want you to tell the shortest distance from you to all other girlfriends. Okay, so there is only one you and you have 4 girlfriends to attend. Okay, so the most basic approach, if you talk about single source, so there is only single source. So single source and we want to find the shortest path, and this is an unweighted graph. There is no weight, every weight is uniform. Okay, uniform or unweighted. Okay, fair enough, whatever it is. Okay, so if it is unweighted and there is a single source and you want from that source to all other recipients, then the thing that comes into picture is BFS. Okay, so you would use breadth first search to calculate the distance from the source to all other nodes. Okay, now how is BFS done? How is BFS done? BFS uses the Q data structure. Let us quickly revision Q also. So basically Q, if you think Q in real life is what? Suppose there is a canteen present. Okay, suppose this is the canteen area. Okay, this is the canteen area. Okay, and there are few people standing. Okay, few persons standing. So the first person standing in the very first position will be the first person to get served from the canteen. So this is known as the front of the queue in programming terms. And a new person comes in, he would not stand here, rather he would be standing here. That is, he would be standing at the back of the queue. So that is what. And NQ means what? NQ means the first person is served and you take him out. So let us quickly see what are the things we learned. The front of the queue is the queue. Front of the queue is the position where the first person would get served from the canteen in this scenario, with respect to this scenario. And whenever a new person comes in, he would come at the back of the queue. This is the second thing. Whenever we want to take out a person, that is known as NQ, is to be done from the front of the queue. Okay, fair enough. This is queue. Now, how is this thing done? What we do is, let us quickly see how it is done. So what we do is, so sublime text, yeah, fair enough. So I would just write the basic one, basic just function itself. So we would initialize a queue data structure, okay, with with integer of pairs. Okay, why pair? Because the first one would store the source and the next one would store the distance. Okay, so suppose this is q. Okay, then what we do is q dot push source. Okay, we push the source towards it and the source will have a distance 0. Why? Because suppose I am at my house and I want to visit my house, then the distance that needs to be traveled from to reach my house is 0. That is why the source will have a distance 0 and we would push that to the queue. Okay, we would quickly initialize s also, whatever, so that we don't have this error thing. So now what we would do is, while the queue is not empty, while the queue is not empty, okay, what we would do is we would take hold of the front of the queue and we would iterate over all of them. If all of them is not visited, we would insert that to the queue. Okay, so we would first tell auto f is equals to q dot front. Okay, then what we would do is we would take out the front of the queue. Okay, q dot pop. Okay, and the front one would get out. The next thing what we would do is we would start iterating on the neighbors of this particular f. Okay, auto e. Okay, auto e, that is, this would return me the neighbors g of this particular f. Okay, vector of, we are iterating on the, yeah, fair enough. Okay, we are iterating on adjacency list. So if visited of e is equals to false, that it is not visited, so what we would do is the distance required to reach at that node plus the distance required to reach the second node would be just +1, because suppose to reach my house I travel 10 kilometers. So to reach my neighbor's house, and it is an unweighted graph, I would require one more iteration, that is +1. So this is the first one is storing the source. So we would write first and then what we would do is q dot push, okay, the e, that is unvisited, with the distance +1, f dot second +1. Okay, whatever the distance was there, we are just pushing it. Now we would one by one visit all the nodes. After all of them is visited, we would get out from this. Okay, so now this is the code of BFS. Quickly tell me if this whole code, simple code, is clear to you or not. Just from line number 8 to line number 16. Just this 8 lines code is required to know beforehand. Even if you don't know beforehand, I'm just telling you. What are we doing is, we are one by one pushing the source. Then we are visiting the source and the source is initialized with 0. So क्या कर रहे, सोर्स को 0 से रख दे रहे और उसके बाद जहां भी जा रहे +1 कर दे रहे, जहां भी जा रहे +1 कर दे रहे, और we are visiting every node exactly once. That is why the time complexity of this is the number of nodes itself. Okay, so quickly tell me if things are clear to you or not, and then we would quickly move forward. Now let's have an upper bound to this waiting, that we would wait for the next 30 next. So let me have the timer. So let's start the timer. So we would wait for the next 30 seconds. Please reply me, okay? Because this question is a kind of difficult, but still I'm starting from the very basic level just because of you. Okay, so at least respect that, okay? And tell me if things are clear to you or not. Okay, 30 seconds have passed. We would now move back. Okay, So this is done. We are iterating over all of this. So let me quickly check. So we are pushing the source, then while the queue is not empty, we are popping the first element, and then we are iterating over the neighbors. If they are not visited, we are visiting it. And the initialization and the other all stuffs, I am not doing it as of now. Okay. So now what I would do is, so we have the question back. Okay. So what I would do is to calculate the shortest distance from this node to all other nodes. What I would do is I would start a BFS. Thanks a lot, Majnoon Neela. Okay. This is done. Now let me take it a little bit up. Okay. Let me increase the difficulty by 0.1%. Okay. Now suppose there is given a matrix. Okay. Now suppose there is given a matrix. Okay, fair enough. And you are told that you first need to be within the boundary, and the next thing what you can do is you need to you can go to all the four direction. You can go up. Okay, you can go up, you can go on the right hand side, you can go on the left hand side, you can go on the down side, four direction. Okay, fair enough. So you suppose I am at this position, this is me, and I can move in all the four direction, but I need to be within the boundary. So if I am at this position, I can reach here, I can reach here, I can reach here, I can reach here. Okay, simple enough, nothing as of stuff. Now suppose I am at this position, then I can reach here, I can reach here. Only two position. Why? Because I need to be within the boundary. That is the first condition. Okay. Now let me make it one level up. Okay. Now suppose, tell me wherever you are not able to understand. Now suppose there is given that there are some blockage over here. Okay. Some blockage. Okay. Some blockage that exist in this, and you can't visit this. Okay. Now suppose I am standing at this position. If I am standing at this position and this is blocked, then I can't visit it. I need to visit this side, I need to visit this side, I need to visit this side. I can visit these all places. Okay. Now suppose I am standing at this position. Okay. Up and down is blocked. This side we are moving out of the boundary. So the only place available is we can visit this side only. Okay. Fair enough. Very simple. So the same thing what we did that side, we would do the same thing now. Now suppose there is your girlfriend 1, there is your girlfriend 2, and there is your girlfriend 3. Okay. Now we are told that we need to visit all the girlfriend moving in 4 direction, and we can't hit the blockage. Okay, we can't move in the blockage, we can't move outside the boundary, we need to iterate over here also. So इसमें भी simple है. What we can do is, instead of traversing over that adjacency list, what are the things that we need to do? The condition that we need to fulfill are, suppose I am at this position, so I can move in this direction, this direction, this direction, and this direction. So what are the checks we need to do before moving in a particular direction? We need to check the boundary. Okay. We need to check the boundary. The next thing what we need to do is, we need to check if suppose it is outside of the boundary. So we would return from that position only. Next thing what we need to do is, we need to check if that is a blockage or not. So we would just write block. Okay, block. So if these two conditions are false, then we can move in that direction. Now moving in right, left, up and down has different things. I would tell you. Okay, I would tell you a way how to traverse in 4 direction. Now suppose I have the index of this is 0, 1. The index of this is 0, 0. The index of this would be 0, 0. This would be 0, 1. This would be 0, 2. And this would be 1, 0. This would be 1, 1. This would be 1, 2. And this would be 2, 0. This would be 2, 1. This would be 2, 2. And this would be 1, 3, and this would be 0, 3, and this would be 2, 3. Now this is enough. Why this is enough, I would tell you. Suppose I am at this position. Okay, I am at this position. So I want to move on the up direction. If I'm moving up, then the x1, the x-axis is getting decremented. Okay, x-axis is getting decremented. So y would remain the same and x-axis would get incremented. So I would just write x plus 1 and y. Okay, if I suppose this is x and this is y. So if I want to move on the up direction, I need to decrease that. I need to decrease that x. So that won't be plus 1, that would be x minus 1. So let me write it here only. Okay, so let it write it here. So to move in the up direction, we need to decrease the x and y would remain same. Now to move on the right hand direction, we can see that x remains the same and y is getting incremented. So x would remain same and y would get incremented. Now to move on the left hand direction, we can see that x remains the same and y is getting decremented. So to move on the left hand direction, x remains the same and y is equals to minus 1. Now to move on the downward direction, okay, x is getting incremented and y remains the same. Now this is quite simple, but why are you telling this? So see, you can traverse in 4 direction by using 4 if statement. Okay, but there is a better alternative to do this. What we can do is, this is minus 1, this is 1, this is minus 1, and the effect of this is 0, 0, and this is 1. So I can write that minus 1, so I can write minus 1, I can write 0, I can write 0, and I can write 1. Why? Because the effect of moving up and down is minus 1, 0, 0, 0, and this is 0, this is plus 1, this is again minus 1, and the effect of this is 0. So now what we can do is, we can have 2 arrays, okay, 2 arrays like this, minus 1, 0, 0, and 1, minus 1, 0, 0, 1, and this is 0, 1, minus 1, 0, 0, 1, minus 1, 0. So you would have noticed, if you have seen the other solution of graph problems, that kind of this array is written in their template, or they have written it. This is the meaning of this. So what they do is, they iterate over the whole array and they add these 2 terms, and they add these 2 terms, and they can iterate in all the 4 directions. They don't need to write. So this is easier. So this is easier, or writing 4 if statement is easier. So I could have shown you using if statement, and that is very intuitive, but I wanted you to save time during the interview. That is why this is required. So now, what are the things we have done till now? Quickly tell me if you are updated till this point or not. Okay, and then we would discuss the original question, and these all learnings will be used in that original question. So what are the things we have learned? We have seen that if there is a graph given and you want to visit all the other, I want the shortest path from the source to all other nodes, that girlfriend one example, then I need to use BFS. Now, and I showed you the code of BFS. The next thing what I did was, I introduced a matrix and I told that we need to be within the matrix and we can move in only 4 direction. Okay, and we saw that yes, it can be done. Next we introduce a blockage kind of thing, and then we told that yes, this can be also done. Just before iterating on 4 direction, just check if it is within the boundary, and if it is not a blockage, then we can go in that direction. Okay, these are the things that we have noticed. And then we noticed that to iterate on all the 4 direction, instead of having 4 if statement, we can have an array where we can just add up the elements and we can move in all the 4 direction. How is it used? I would tell you. Now moving forward, we would read the problem statement. Okay, so you can just ignore this. I think you have already read this. So you are given a blueprint of m cross n, which is a matrix. So you are given a matrix of m cross n, and that is filled with characters O, B, and W. What are the characters? So 0 represents an open space. So 0 means that is empty, and B represents a bomb. Okay, so B is basically nothing but a blockage. So you can see that this is blocked, and 0 means it is available. Okay, and W means represent a wall. Okay, now V, so sorry, this B would be bomb, so that would be source. Okay, and W is the blockage. Sorry, I thought that bomb is the blockage. Okay, W is the wall, that is the blockage. So you need to replace all the zeros in the matrix with their shortest distance from the bomb. Okay, shortest distance from the bomb. But the problem here arises is, so what you need to do is, so you are given a matrix, okay, of n cross m, or m cross n, okay, m cross n, and what you need to do is you need to tell the distances from all, so distances of all the open space from the bomb. But so what you can do is, bomb can be visualized as you, and open space can be visualized as your girlfriends. Same question, backward question. But the problem here is that the bomb has multiple occurrence. The bomb has multiple occurrence. Earlier the question that we have discussed was that there was only one source, and we need to visit the whole graph, whatever is empty. But here we can see that the sources are multiple. Okay, the source is multiple. So multi-source, so multi-source shortest path, and this is an unweighted graph. No weight is there in unweighted graph. Okay, in unweighted graph. Now the next thing that is required is, so can you quickly like the video if possible, please? Okay, so now what I can do is, I can take hold of this source and I can do a BFS, and then I can take hold of this source, I can do a BFS. Okay, fair enough, this I can do. So basically we would be going on all the sources and we would be doing a BFS, and the same old thing can be done. But I'm telling you that a simple one line modification or a one word modification can solve this problem. So this is nothing but multi-source BFS. So multi-source BFS seems to be a little hard in the first place, but if you know BFS, then that is absolutely a cakewalk, to be honest. Okay, how it is a cakewalk? The only modification that you need to do in the old code is, so I would just be writing old, whatever the old code you were writing, just the only modification that you need to add is insert all sources. Just this, insert all the sources. This is the only modification that you need to do. So basically, let us go back to our code. So here we are pushing only one source with 0. The only thing that you need to do is, you need to iterate on all of the matrix, and whenever there is a bomb, you need to insert that to the queue and start, and this whole code would remain the same. So this whole code would remain the same. Okay, so I would just comment it, and this code would also remain the same. I would just comment it. The only thing that you need to do is, you need to insert all the sources in the queue. The only difference thing. So let's move to the code and you would understand it much better. Okay, now what are we doing is, we are having a queue, okay, of pair int and int. Why? Because we would be storing the distance. So here int and int means the first int would act as a x-axis and the next int would act as a y-axis. Okay, so what are we doing is, if it is a bomb, so every bomb is a source, I told that. So what are we doing is, we are initializing the distance with 0 and then we are pushing that to the queue. I just told this and I am doing this. And next what I'm doing is, if it is a wall, I am initializing it with -1 because this is an integer array. Okay, and it is already told that all the walls should be represented with should be replaced with -1. So all the walls should be replaced with -1. I'm doing it. And जितने भी sources है सबको insert कर दो queue में और distance उनका 0 कर दो. सारे sources का distance 0 करना है, सारे source को queue में insert करना है. The only difference thing. Now we would have the same old dx and dy, the same thing that we have written at this position. See, the same thing I am writing here also, to quickly iterate in all the 4 directions. This is the reason for the person who are good with data structure and algorithm use this array to save their time. Okay. Now, while the queue is not empty, we are taking I and j and we are popping out. The same old thing we are doing. Now we are having a for loop of size 4 to iterate over this array. This and this. So what are the things we need? So I am first adding dx and dy. So the new one should be within the boundary and it should not be a blockage. So it should be within the boundary. So this is greater than 0. Yes, it is. It is less than this. It is. It is less than this. This is. So this is checking the boundary. Okay. Boundary. So I would just be writing this boundary option. And then this is checking if it is valid or not. If it is not wall or not. So I would just write wall. Okay. And if this, by doing the current thing, we are able to amplify more on the result. Suppose by visiting this, we can, so what you can do is, you can have a visited array, or the same thing, but if you don't want another auxiliary array, what you can do is, you can say that if I can improve on the distance, current distance, then I would be improving it and I would be inserting that to the queue. Okay, I would be doing that. Next, I would be, whatever things are initialized with int maximum, to see what are the phases that we can't visit. So whatever is the blind spot, we are initializing that with -1, and this is told in the question only. The sources that the recipient that we can't visit will be initialized with -1, and I am doing that. Next, we are returning the answer itself. Okay, we are returning that. Now, just a quick follow up. So just a quick follow up, that this multi-source BFS can be used with Dijkstra also. The same old Dijkstra code would be used. Just add the sources like we added in the BFS. So BFS का पुराना code plus adding all the source with distance 0 will be multi-source BFS. Dijkstra का पुराना code, उस पे सारे sources को पहले insert कर दो, will be multi-source Dijkstra. And this is just so easy. कुछ points है, जैसे iterating over the matrix. Iterating over the matrix means that we need to, suppose it is given that we can move in 8 direction, we can move in 4 direction, we can either move in up and down, which is a dynamic programming question. All this can be done. Okay. Now tell me if things are clear to you or not, and I would be turning off the session after this 30 seconds or 30 seconds ends. Okay. So quickly tell me if you are done with the question or not. Else quickly ask your doubt. And if you are watching this after the live stream, consider asking your doubts on LinkedIn, or you can ask here also by tagging me. Okay. My LinkedIn username is Siddharth Hazra, SIDDHARTHAHZRA. Okay. So I see no doubts coming in. Okay, I see no doubts coming in, so I would be turning this session off. Okay. Thanks a lot for attending this session. Keep practicing.